Sathyabama Institute of Science and Technology.
So myself Karthic, Assistant Professor in Mathematics from Sathyabama Institute of Science and Technology, Chennai. So in the last class we have seen the topic correlation and its several types using the data less than 20 and more than 20 of the independent and dependent variables, and also with rank correlation, and the rank is repeated as well as the non-repeated. So here in this class we are going to discuss about regression with examples. Let's see this topic today. In the last class we have seen the correlations. So here we are going to look at the topic regression. So regression is also similarly same to the correlation formulas. So here we are going to look at about independent and dependent variables. So the relation between independent and dependent variable is called regression. Here based on these things and based on the independent variable, whatever the value we are going to substitute, we can find the dependent variable. For example, let the independent variable be x and the dependent variable be y. So based on this, if you are going to find a equation, that's nothing but the regression line. So the regression line y equal to m1x plus c. So that you know already, right? It seems like a straight line. In this, x is an independent variable. So based on the independent variable, if you substitute whatever the data, you will have dependent variable y, right? So the value will be calculated based on that. So it helps in predicting the value of the dependent variable based on the independent variables. So here we have two types: simple linear regression and multiple regression. So simple, which will be based on two variables only, x and y, one independent and one dependent variable. Multiple regression is nothing but one dependent variable and two or more independent variables. And we are going to look at about linear regression for simple one. So that's nothing but regression line or regression equation of x on y as well as y on x. Both are slightly changed, otherwise everything is same. Look at that, x on y is nothing but we are having the formula x minus x bar equal to bxy into y minus y bar. In y on x, just opposite to this, y minus y bar equal to byx into x minus x bar. Here bxy and byx are the regression coefficients, and we know already that what is x bar and y bar, which is nothing but mean of x and mean of y. Here the most important thing is we need to find bxy. So bxy having the formula already I told you, right, which is similar to correlation. So the correlation formula will be modified just like this. Here also we have two options. One is nothing but when the data are less than 20, we can use this formula. If the data are more than 20, we're going to use the deviation formula, just a small difference. And the change is in the denominator only. If it is bxy, so y will be the only dominating denominator term. So n summation y square minus summation y square. If it is y on x, means in the denominator will be n summation x square minus summation x the whole square. Okay, there in correlation we used root of x term, root of y term. Here we are not going to use like that. bxy having y in the denominator and byx will have x in the denominator. So this is the only thing which is same in the deviation method also. So here d and d will be additionally along with them. This is only for when x and y less than 20. Here x and y is greater than 20. Now let's see a topic. We can find correlation by the value of regression coefficient. I told you already, right? bxy and byx are the nothing but the regression coefficients. So the additional formula to find correlation that we have already seen, correlation is equal to root of the regression coefficients multiplications, bxy into byx. At the same time, when they have given regression coefficients and along with the correlation, then the standard deviations sigma x and sigma y, we can find the regression coefficients also. It is only when they have given standard deviation and correlation. Let's see some problem on this. Here, as I told already, the data are less than 20. Take x as it is, y as it is, there is no changes on that. After that, square x directly, y as well as directly, then multiply x into y together. After that, take summation for all this, so that we can take summation x, summation y. Why I am telling summation x and summation y also means in the formula we are going to use x bar and y bar to find the regression line of x on y as well as y on x, so that summation x, summation y. Based on this, we are going to find x bar, y bar. Then summation x square, summation y square, summation xy. The calculation will be regression line of x on y one side, regression line of y on x another side, so which will be easily comparable to you. So here the formula for x on y and formula for y on x, formula for bxy, byx. As I told already, x bar will be 15 based on the formula, y bar will be 20. Then substitute the values in bxy so that the value will be like this. After that, the calculation, the final result will be bxy equal to, you just take two decimal places only, so just like this 0.83. Similarly here also byx, its formula, substitute the values here so that the byx value will be 1.13 as a rounded figure. Finally, substitute the data into the regression line of x on y and y on x as well as, so that x minus 15 equal to bxy value y minus y bar. Here also the same similarly. Then we need x in a side just for x on y, we need y in a side just for y on x. So you just multiply and simplify the terms, the final result will be x equal to 0.83 y minus 1.5, and here y equal to 1.13 x plus 3.11, which is a regression equation of x on y as well as y on x. And as I told, we're gonna see a problem based on the datas are greater than 20, so there is nothing but ages and blood pressures. So here additionally we have the questions, regression equation of x on y, y on x, which is as usual. Additionally, look at the second one, correlation coefficient or using regression coefficients, as we already see in the formula. And the last one, I told you already in the beginning when we have taken the topic regression, that's nothing but we can find the dependent value using the independent value. Just based on that, C, estimate the blood pressure, which is nothing but the dependent value, using the value age is nothing but here independent value. So the given datas are greater than 20, as we discussed already, use deviation method. For deviation method I need x bar as well as y bar. X bar is nothing but 50, y bar is nothing but 100. So dx dy seems like this. Then the table will be x as it is, y as it is, take summation for that. Dx will be x minus x bar value, dy will be y minus y bar value, and square those terms, dy square dx into dy. Once you have done this, then substitute all these values into the equation already we have applied to the datas which is less than 20. Look at this regression line or regression equation of x on y as well as y on x. As usual, same formula, bxy, byx formula, substitute all the datas. Bxy will be minus 0.11 here, byx will be minus 0.14 here, so that the regression line of x on y finally will be x equal to minus 0.11 y plus 61, and here regression equation of y on x will be y equal to minus 0.14 x plus 107. This is for the first question. Second one is, we are going to find the correlation using regression coefficient. So r equal to root of the multiplication of two regression coefficients, that is nothing but this. Minus minus will be plus, inside the root, once you are going to take root outside, there will be plus or minus 0.124. So here the correlation coefficient either positive or negative. The last one, here we are going to find dependent of blood pressure using x value. So to find y, we have two equations. So we just take y equation, y equal to minus 0.14 x plus 107. Substitute x value so that we can find y equal to 100.7 or as rounded figure 101. And the last topic here, it is multiple regression. So multiple regression is nothing but there are several independent variable. There will be only one dependent variable. So just like a plus b x1 plus c x2, it's not only up to x2, we can extend this d x3, e x4 and so on. It's based on number of terms exist in the given data. So the process is, if this is your multiple regression equation, then its normal equations will be this one, just to find the unknown commodity A, B, C. To find this, we are going to use a normal standard equation, standard normal equation. This one is standard and this is its normal equations. Here, based on A, B, C, we are going to construct the normal equations just like this, NA plus B summation x1 plus C summation x2 equal to summation y. Next step, multiply x1 to the entire, then multiply x2 to the entire, so that the normal equation will be the hint to follow the theme. Then we have a question here. The datas are nothing but radio advertisement, the datas, newspaper advertisement, the datas. So here they have given two independent variables only based on the advertisements, and based on the advertisement the sales value will be sales equal to 7, 12, 17 and 20. Okay, here we are going to find the regression equation. So obviously we can understand that this is multiple regression. So the equation will be y equal to a plus bx1 plus cx2. Before that, what are all the data needed in the normal equation we are going to find using this table. That's nothing but, let the first independent variable will be x1, another independent variable will be x2, and the dependent is y. Here in the normal equation the data needed x1 square, x2 square and its summation, x1 x2, x1 y, x2 into y. So apply all the terms together, multiply and square, finally take the summation for those things. The result will be the summation values just like this. Then substitute these data into the formula. The formula is nothing but the normal equations, 4a plus 32b plus 16c, which is equal to 56, and the second equation you just substitute the values, and in the third you just substitute the values. So once we have done this, you can use any method to find ABC. You can use solving 2 equations to find ABC, or you can use rank method to find ABC. You can use some other method which is convenient to you. You can use any method to find ABC. So finally we have the result of ABC is nothing but a equal to this, b equal to this and c equal to. And we know the regression equation formula is nothing but y equal to a plus bx1 plus cx2. You just substitute the value. So we have the regression equation, this one. That's all for today's class. Thank you all.